Welcome to Electronics Techie. So in this video we discuss about 4-bit divider. So 4-bit divider is nothing but when you are going to give some values, like we already know what is the division rule, what is the how you can going to divide. So there is a value like dividend. We have to consider any divisor for divisor purpose. So now going to 5 to the 5 6 are 30, so it is going to be 0. This 6 is called as coefficient. This 0 is going to be remainder. So it is the basic concept of the division. So if you consider any other value, so 4 and then 16, if you take 17, then 4 4s are 16 and we are going to 0. 1 is our remainder, so it is our coefficient, it is our remainder like that. So now what we are going to do until the remainder is less than means divisor, then your operation is going to be performed. So if you consider 2 say power like something 32, then we are going to what you are going to do 2 1s are 2 and 1 2. Again this value is so 2 12 is less than 2, so it is not correct. So we are going to do the next again the same step. So 2 6 are 12 and the remainder is 0. So it is our coefficient, it is our remainder. So until this condition is going to be satisfied, remainder is less than or equal to divisor, then our operation is going to be done. So this is our final code. I think this is the main basic code when you are writing Verilog code. So see, this is our division code. So for that I write module and followed by end module and then. So module followed by there is a module name. So you can take any module name. So what is our inputs? So we are going to give the dividend and divisor. So these are the inputs. So this should be a 4-bit I consider. You can take any bits, but I take 4 bits. So that means 3 down to 0. So output, what is our output? Coefficient and remainder. So for that purpose there is a always block, that why we should mention the output port as reg data type. So always at the rate star is nothing but our sensitivity list, which means all the inputs. So all the inputs, if any change in any input, it is going to be exhibit the whole block. So now begin. So what you are going to do, first initially you are going to make it as coefficient value is equal to 0. So our remainder value is equal to dividend. So dividend means what is the inside the bracket value. So if you consider 15 and then 3, so inside the value is going to be dividend. It is also our remainder. So it is a dividend and it is also our remainder. So 3 is nothing but our divisor. So don't confusion between divisor and dividend. So our dividend is going to be our remainder. So while remainder is greater than or equal to division, so whenever the remainder is going to means remainder means 15 value is greater than 3, okay, it is correct. So then only you can go into this loop. If it is false, don't go into this loop. So just greater than or equal to 3, then you are going to inside the loop. So begin remainder equal to remainder minus divisor. So remainder is equal to, so what is our remainder now? 15 minus what is our divisor? 3. So our new remainder is our 12. So like this the coefficient value is going to be 1. So coefficient is equal to coefficient plus 1. So 0 plus 1 is nothing but 1. So our new coefficient value is equal to 1 and our remainder is going to be 12. Again we can go to the while loop. So you all know about the while loop. While loop is until this condition is going to be fail. Until the condition fail, it is going to be executed. So again come to this, what is our remainder? Our remainder is 12 greater than or equal to divisor. What is our divisor? 3. So again it is correct. So go into the loop. So again 12 minus 3 is nothing but 9. So it is rearrange like remainder as 9 and our coefficient is going to be 2. And again going to the while loop, and what is our value like again what is our 9, remainder is our 9 greater than or equal to 3, again correct. So next remainder equal to remainder minus 1. So 9 minus 3 is nothing but 6. So the again remainder is assigned to be 6 and our coefficient value is going to be 3. Like that again going to the condition and its value is going to be 3 and 3 minus 3 is nothing but 0 and the value like that it will execute until the value is going to be less than or equal to divisor. So if it is less than means, so this loop will going to be stopped. So after this while begin, so it will be end here. So here always begin is going to be end here and module will be the end module. So finally our coefficient will be the 5 and our remainder going to be 0. for this example. If it is another example, it may be some, if you take any value, so 12 divided by 6 means our coefficient is equal to 2 and remainder is equal to 0. Like that you can take any value. So 15 by 4 means 4 3 is our 12 is our coefficient and remainder is our 3 value. So both are same. So here is the example of test bench code. Here we consider one of the example in test bench code. The test bench code of the 4-bit divisor is like this. So module followed by module name here. So inputs are in reg data type, so outputs are in wire data type. So next we have to instance the design code module in the test bench code module. How we are going to means, so first we have to write the design code module name. So design code module name it is. So DUT means it is our instance name. We can use any instance name here. DUT is nothing but design under test. So this is our port connections. So port connection, how you're going to connect the ports is already have separate video. So if you don't watch, you can go and watch that, then you can understand properly about the port connections. So initial begin, in the initial begin block, we are going to give the different combination of input. So input combination you are going to give and cross check the values in the output waveform. So there is some delay we can give, and then if you want to stop the simulation, you can simply use the finish keyword. For stop the simulation, we are going to use the finish keyword. $finish is our keyword for the stop the simulation purpose. So initial begin is going to be end here. So module is followed by end with end module. So it is our test bench code. So what is our divisor value is 4 and dividend value is 7. So 4 ones are 4. So the remainder is 3. So this is our coefficient, this is our remainder. So cross check in the waveform. So see the waveform. So divisor is equal to 4 and the dividend equal to 7. So the coefficient will be going to be 1 and the remainder is going to be 3. Like that we can cross check whether your code is correct or not. So it's fine. So I think this code is clear. So if you have any doubts in any particular example, if you want any example and if you want more bits of this code, if you get any error, you can unsolve that. Please comment it. If you have any problem while you are doing the code, then also you can comment it. So until then, thanks for watching and then bye.